I wanted to make a video of one problem from the Day 6 lesson. It's a higher level thinking problem, and it was example 3. And this is a type of problem that you should be able to do, even though it requires you to put together a few different pieces of information. That's what makes it a higher level thinking question. So on a test or something, the question probably wouldn't be exactly the same as this one. Otherwise, it's not really a higher level thinking problem anymore, because you can just sort of copy what I did instead of thinking for yourself. But this will give you a feel for the type of level of question that you will need to be able to answer if you're shooting for the A. Okay, so example 3. The height of a parallelogram is 3 times its base. Okay, if the area of the parallelogram is 972 square inches, find its base and height. Okay, so there are a couple different things here. The height of a parallelogram is 3 times its base. I'm going to come back to that. Look, when I read that, as soon as I see that phrase, the height of a parallelogram is 3 times its base, I'm thinking this equation in my mind. The height is 3 times the base. Okay, that's what that equation should tell you. The height of a parallelogram is 3 times its base. That translates into that equation right there. Now then, the next sentence. The area of a parallelogram is 972 square inches. Now they're mentioning area, but we know a formula for the area of a parallelogram. So we know the area for a parallelogram is base times height. Well, there's that base and height again. So if they're telling us that the area is 972, that means I should be able to substitute that in. So that means 972, the area, should equal base times height. Okay, but now we also have this other little equation that they indirectly gave us by telling us that the height is 3 times the base. Okay, so the height here, h equals 3b. Height is 3 times the base. So if I wanted to, I should be able to do this substitution. Okay, h equals 3b. So if I wanted to, I should be able to take this h and replace it with 3b. So let's see what that would look like. So this would become 972 equals base. Alright, now I'm taking out height, and instead, because height equals 3 times the base, so I'm going to replace height with 3 times the base, 3b. The point of doing that is now I have an equation with only one variable instead of 2. So this is an equation I should be able to solve. What's b times b? Hopefully you know that b times b is b squared. So this would be 3b squared. Now to solve this, I need to get b by itself. So I would definitely want to divide both sides by 3 like this. Okay, let's wrap that around. Okay, so if you divide by 3, you're going to get 324. So this gives us 324 is equal to b squared. Alright, just dividing by 3. And it's time to take the square root of both sides. So square root, square root. So that's going to give me b equals 18. Okay, so that's one of the things we were supposed to find. It says find its base and height. We just found the base, now we need to find the height. Well, remember this little formula that we have? Let's write that down again. The height is 3 times the base. So now that we know that the base is 18, that tells us the height should be 3 times 18. Okay, in other words, I'm taking this base that we just found and I'm putting that in right there. Okay, and 3 times 18 is 54. So that tells us that the height is 54. Okay, so there's the base and height that we were supposed to find. So that's the first half of example 3. Now if I were you, if you're watching this video, you should pause the video right now. So I've given you one example, and so part B is almost the same thing. So, but it's slightly different. So right at the moment, it still would be sort of a higher level thinking question for you. So pause the video, please, and try to do part B on your own. And don't give up immediately. Part of a higher level thinking question is you have to struggle with it for a while. You have to play around with it and put some effort, some thought into it. A lot of times students will just give up almost immediately if it doesn't if it's not obvious to you what you're supposed to do. So go try the problem. Pause the tape now. Okay, so maybe you paused it, maybe you didn't. I have no way of knowing. But if you just watch me do it and then just copy me, that's definitely not higher level thinking, and that's not the best way to learn. So I hope you did pause the video, and now you're just checking your answer. Now we're talking about a kite. Okay, the diagonal of a kite is 4 times as long as the other diagonal. Okay, now you remember with a kite or a rhombus, we talk about the diagonals as diagonal 1 and diagonal 2. So this sentence that says one diagonal is 4 times as long as the other, when I hear that, here's the equation that comes to my mind from that. One diagonal, so diagonal 1 is 4 times as long as the other, so that should equal 4 times the other, so 4 times diagonal 2. So that's the little equation that comes to my mind from that. Okay, in the same way that the h equals 3b came from this first sentence here. Now what? The area of the kite is 72 square meters. Okay, so just like before, we're given the area. Alright, so again, let's start off knowing the formula for the area of a kite. Okay, the area of a kite is 1/2 diagonal 1 times diagonal 2. So they are giving us that the area is 72. Okay, so that means I can take this 72 and put it in for area in this formula. So this will become 72 equals 1/2 diagonal 1 times diagonal 2. Alright, I still have 2 variables though, so it would be nice to substitute and get rid of one of these variables. Okay, now let's do another substitution. I took this area formula, but they gave us the 72 as the area, and I substituted that in, and here it is. But we also have this. Alright, diagonal 1 is equal to 4 times diagonal 2. So if diagonal 1 equals this, I should be able to take this and substitute it in for diagonal 1. So if I do that substitution, this equation becomes 72 equals 1/2. Now I'm substituting for diagonal 1, so I'm going to leave a little room. Diagonal 2. So diagonal 1 equals 4 times diagonal 2. So I'm going to replace diagonal 1 here with 4 times diagonal 2. Okay, so I just need to simplify this. Now, 1/2 times 4, that's half of 4. So what's half of 4? Yeah, half of 4 is 2. So this becomes 72 equals 2 times. Now, diagonal 2 times diagonal 2. Well, that is just diagonal 2 squared. Okay, I'm going to leave this in parentheses because of the whole little sub 2 thing. So this is diagonal 2 squared. Alright, anything times itself is squared. If I divide both sides by 2, alright, trying to get that diagonal 2 by itself, then I have 36. Okay, so diagonal 2 squared is now equal to 36. So if I want to get diagonal 2 finally by itself, I need to take the square root of both sides. Okay, so if I go ahead and take the square root of both sides, then that's going to give me diagonal 2, because that radical will unsquare this, and this is going to give me 6. Okay, so that is one of the diagonals. Alright, we're supposed to find the length of the diagonals, so we're supposed to find both diagonals. So far we found diagonal 2. So now we will find diagonal 1. But we can do that by taking the answer that we just found. We just found diagonal 2. So we can take this and substitute it back in to find diagonal 1. So this is going to become diagonal 1. They told us it was 4 times diagonal 2. So now we can see that that's going to be 4 times 6. So that means diagonal 1 is 24. Okay, now I know that was a tough problem, and you can definitely pass a test without being able to do a problem on this level. This is a higher level thinking question. But I feel that all of you have the ability to do a problem on this level. It's just going to take some practice.